Hi, grade 6. This is the math video for page 214, which is a mid-chapter practice test. Page 214. Number 1 says define prime number and give an example. Well, it also says in red lettering, lesson 5-1. You're going to need to write a sentence that describes what a prime number is. And then you're also going to need to give an example of a prime number. There's millions of them out there. Number 2, describe how you know when a fraction is in simplest form. For example, here's two fractions. Which one of them is in simplest form? The bottom one. But how do we know that? That's going to need a sentence to describe how we know. In this case, with this one, I can divide out of it a common factor. Maybe I just helped you with that. But with this one, there is no common factor I can divide out of them, right? Number 3, determine whether 24 is prime or composite. Well, I'm not going to do 24, but what if it said 20? Is 20 prime or composite? Well, I know that I can get to 20 by doing any one of these math problems. It's got to be composite because we know that the definition for a prime number talks about the fact that there's only the number and the number 1 as a factor of that number. 4, 5, and 6, they're asking you to factor certain numbers or expressions. What if I had a number like 36? How would I factor that? Well, I'd probably use a factor tree. And I would come up with 2 times 2 times 3 times 3 as the factoring of 36. What if I included some variables like number 7? It's no big deal. What if it was 36 times m times t? Well, it would just simply be that same answer I got previously, but I would attach to the end times m times t. Now, that x is getting a little confusing, so I'm probably going to change these x's to dots to make it easier to identify what I'm actually talking about there. How about 8 through 11? Do you remember how to find greatest common factor? Hopefully you do. Let's do one like, how about 14 and 30? 14 and 30. Well, there's two methods. What are the factors of 14? 1 and 14, 2 and 7. The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. What's the greatest factor they have in common? They have 1s and 2s in common, so the greatest common factor is 2. That's one way to do it. The other way is to write out the prime factorization of each one of the numbers. And in this particular case, they have one set of 2's in common. So again, the greatest common factor is 2. How do you do it when they have variables involved? Not really that big of a deal. Let's say I had, 20x squared, and I was trying to find the greatest common factor of that and say 32x squared t, right? If it were me, I'd write out the prime factorization of each number. You'll notice I'm changing all the multiplication signs into dots to make it a little easier to think about. And now what do they have in common? A set of 2's. Hey, another set of 2's. A set of x's, another set of x's. Do they have anything else in common? Nope. So my greatest common factor is 4 times x squared. 4 times x squared in this particular case. Number 12. The gear ratio is the comparison of the number of teeth on the chain wheel to the number on the free wheel. If the gear ratio is 52 to 16, write this fraction in simplest form. That's a pretty easy problem, actually. All they're asking you to do is to take this fraction and simplify it. That's all they're really asking. And yes, it is able to be simplified. I can divide both of those numbers by 2. I can also divide them both by 4. Let's go on to 13 through 15. How do we change a fraction into a decimal number? Well, if I had 5/8, I would take the top number divided by the bottom number. 8 goes into 5 0 times. But if I bring down a 0, 8 goes into 50 6 times. If I bring down another 0, 8 goes into 20 twice. And if I bring down another 0, 8 goes into 40 5 times. So I get an answer of 0.625. 0.625. What if I have a mixed number? What if it was something like 4 and 5/8? Well, then the answer would be 4.625, wouldn't it? 4 and the 5/8, 4 and the 0.625. 4 and this is 4.625. How about 16 through 20, where you're changing decimal numbers back into fractions? That shouldn't be too hard, right? If I had, let's say, for example, 0.4, another way to say that is 4/10 because it's filling the 10th spot, and that can simplify to 2/5, right? What if I had 6.08? That would be 6 and 8/100ths, because the 8 occupies the 100th spot. And then I can simplify that. Let's divide by 4, and I get 6 and 2/25. How about 19? 19 is just the greatest common factor problem of 8, 64, and 96. What's the biggest factor that 8, 64, and 96 have in common? And the last one, Amy spent 35 minutes in the afternoon practicing the piano. What part of 1 hour did she spend practicing? Write it as a fraction in simplest form. I'm not going to do that problem. But what if the problem said that she spent 45 minutes practicing? What portion of an hour is 45 minutes as a fraction? Well, I know that an hour is 60 minutes. So I would write it as 45/60ths, 45 minutes out of a total of 60. And that, if I divide by 15, in simplified form, is 3/4. So do number 20 similar to that. Okay, thank you. Have a good day.